Okay, so today we are going to talk about taking derivatives of logarithms, okay, whether it's base E or a different base. Now I will tell you when you go to do your homework, you're going to go to chapter 5, okay? I don't know why, but our calculus book has anything that deals with logarithms and exponents in chapter 5. Well, I want to do all of our derivatives together, okay? So we're pulling from like 3 different sections in chapter 5 so we can do all of our derivatives together, okay? Before we talk about taking derivatives with logarithms, we do need to review their properties, okay? So very quickly, there's 3 properties that we talk about when we expand and condense logarithms. At your pod, please verbalize to each other what are those 3 properties when we expand and condense. They might deal with, I don't know, multiplication, division,
I can do it. I just don't know what it was like. Remember, if it's like log, if I go to the front, I just go 5 log. But if it's like log 5x, so it's log 5 plus log 5. You get it?
All right. What happens, think about it, what happens if we have multiplication inside of our logarithm? If we have multiplication inside of our logarithm, Colby, I'm going to have you speak for pod 1. What do we do with our logarithms?
So like, when we have multiplication, we're like rewriting it, we like add the 2.
Okay. If we I forgot I had this blank. If we multiply, then we're going to take our 2 logarithms and add them together. Okay? Or vice versa. If we have 2 logarithms that are being added together, we can rewrite it as 1 logarithm with multiplication inside. There's a fly in my room. Catch it? I'll give you a piece of candy. Okay. Okay, if there is division inside of our logarithm, Aaron, you're going to speak for pod 8. What do we do with our 2 logarithms? Okay. And vice versa. If we have subtraction between 2 logarithms, we can condense it down to 1 logarithm with division inside. Okay. Last but not least, that's really the only one we're going to talk about. If we have a power inside of our logarithm, Chris, what can we do with that power?
Don't you like bring it in front?
We can multiply it out in front.
Oh, this is R. I thought it said 1. Yes, that's 1.
I mean, technically, we could say 1. What's really funny is watching people written.
I'm gonna catch it.
Okay. Okay, so before we get into the calculus, let's at least talk about expanding. Okay? Are you writing that one down?
Get it.
Your time is fast. Okay. All right, Mrs. Holman, we didn't talk about radicals. What? No, the half power. Okay, so we like to think of this as log base 5 x plus 1 to the 1/2 power divided by x. Okay? So when we go to rewrite this as an expansion, okay, since there is division inside, we can write this as the difference. Okay? And since there's a power inside, we can throw it out in front. This is so 2 years ago, isn't it? Okay? To give you some confidence before we start our calculus, please expand that one for me. E is the base of natural log. Check it with your neighbor to make sure they have the same. All right, you know what do you have?
Parentheses 3 natural log x plus 3 parentheses plus natural log x plus 1 minus 1/3 ln x plus 10.
Okay. And since we're going from left to right, you probably don't need these parentheses right here. Okay. Order of operations, left to right, we perform them in if they're tied. Okay, here we go. Okay, now let's talk about the calculus side, and we'll eventually get to how can expanding a logarithm actually help us in the calculus part of it. So here's another rule for you to remember. The derivative of the natural log of x, the derivative of the natural log of x is 1 over x. Circle it, highlight it, star it, box it, I don't know, do something so it draws your attention.
Did you get it?
No, I was ordering it from the book, sorry. I was like, why did you? Okay, let's talk about if we have the composition, if we have something inside of our logarithm. Okay, if we have something inside of our logarithm of f of x, or the natural log, excuse me, of f of x, then it's still the same thing. 1 over what's inside times the derivative of what's inside. Okay, so you see the natural log, its derivative is 1 over what's inside times chain rule. Okay, it's actually a pretty nice rule if you ask me.
So really, it's just what's inside.
Yes. Okay, Colby just said, so basically it's the derivative of what's inside over what's inside. If you'd like to think of it that way, you're more than welcome to. Okay? So let's do like 5 examples and then I'll tell you, well, what happens if we don't have E as our base. Okay, we'll start with this one. Y equals the natural log of 2x. Y equals the natural log of 2x. Okay. Well, a natural log's derivative is 1 over what's inside. Am I done? Times chain rule. Derivative of what's inside would be? And then I'm just going to simplify it 1 over x. Because we can do that simplification, right? You don't think so? Next one.
Because you have to multiply by the derivative of what's on the inside, 2x. So the derivative of 2x is what? 2.
Try this without me. Too soon?
Any training.
Think about it or write it down, but I want you to just. The derivative of any natural log is 1 over, copy paste, right? But what's the derivative of x squared plus 1? So we have 2x over x squared plus 1. How was it without training wheels? Okay. Hey, and what happens if you fall over?
Just
Get
get
back
back
up.
up.
Get back up and you try again. All right, write this one down.
Oh, shoot.
Nicole, what do you notice about this one? It's a product. Not to fear. We know how to do derivatives of products, don't we?
Yeah, sure.
Okay. Oh, man. Okay. Help me out. The derivative of x times natural log of x plus x times the derivative of natural log x
1 over x.
is 1 over x. So what do we end up with? Natural log of x plus 1. X times 1 over x. Okay. I kind of wrote it funny. And if you leave it like this, is it okay? Of course. Of course. Yes.
No.
You're killing me. If you want to miss time, then that's your decision. Grab a pen. If you want to, you can.
I'll do one more.
There's the guilt for it.
I just gotta get it.
Before we go through how to find the derivative, take 15 seconds to brainstorm. What do we do first? What do we do second?
You're going to pull the other function, and that would be that's my
All right, time's up. Dylan, speak for pod 3. And what?
What?
This is what pod 3 had to say. How do you feel about it? Okay, we have something cubed, so we take the derivative of that. So power rule, 3 goes out in front, decrease power by 1. But inside of our cubic function is natural log of x, so the derivative of natural log of x is 1 over x.
Yeah, I know. It just like flies in front of the
Just
screen.
go to
It
the-
drives me nuts.
All right, write this one down. Okay, I don't know if you're making comments about the fly or the problem, but if you're making comments about the problem, what's the issue that you are? There's a lot going on, isn't there? Right? Do you really want to take the derivative when we do the chain rule of the cubed root of quotient? Okay, but it's inside of a logarithm, so is this our only option of how to write it? No, it is not. We could write this as 1/3 times the natural log of x minus 1 minus the natural log of x plus 1. Right?
You have Prince.
Okay. Would you like to give 1/3 to each part?
Yes.
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 Who votes yes? Who votes no?
Yeah, you
I have more yeses. I have more yeses. Does it matter? No. Okay. So now what we can do for the derivative, instead of having to do a chain rule involving the power rule and the quotient rule, okay. So we have 1/3 times the derivative of this is 1 over x minus 1 times what's the derivative of inside? 1, right? Minus 1/3 times the derivative of this natural log. Okay, the derivative of the natural log is 1 over copy paste times the derivative of the inside, which would be 1. And guess what? I don't make you simplify. I don't need you to subtract these two fractions. You can leave it like this. Isn't that way better than having to do any sort of quotient rule inside of the chain rule? Yes.
Why didn't we have to do the product rule for each one? Or like,
Well, because this is 1/3 times the natural log. If it's a constant, it's just going to stay along for the ride.
okay.
Is that what you're asking about, the 1/3?
Yeah.
You can do the product rule, but the derivative of 1/3 is 0, so half of your product rule is going to go away anyway. So make it easier on yourself. Just bring it down with the derivative.
Okay.
Okay? All right. Awesome. Okay. Okay, so
Yeah.
what happens if it is not base E? So this is going to be your next rule. Write it down. The derivative of a log with base A instead of base E. I usually go through why this is a thing. I'm going to just We're just going to go straight forward, okay? So it's still 1 over x, but since the base is not e, we have a little bit extra to it. Okay. 1 over x times the natural log of the base. Well, if our base is e, the natural log of e is 1, so you don't see that in our natural log derivative. But if the base is not e, then we have to show that. Okay? If you have the derivative of log base a of a function inside, okay, let's just talk about, we're still going to have to work with the chain rule. 1 over what's inside times natural log of the base times the derivative of what's inside. Okay. Highlight, star, box, circle. I don't care what you do, but here's another rule that you will be expected to remember.
On the AP exam, will we get all the rules, or we're going to know all of them?
You need to know them.
Are you actually?
Let me just tell you something. We're going to use them enough. Okay? You're going to know them and it's going to be fun. And those of you who are scared about the AP test, you're going to be ready for it, whether you sign up for it or not, because we're going to do that much review at the end of the year. Yes.
When is like dual enrollment?
We won't talk about that till January. Okay? So let's just see how this semester goes and then we'll make some decisions. Okay?
Like, where to take the AP test, you don't have to do the final.
No, nothing.
Oh.
Okay, we're going to do these two derivatives. Okay? Some of you who are like trying to make decisions right now, just remember that if you dual enroll, your grade follows you. And if you have a scholarship that depends on you keeping like a 3.75 or a 3.5, you don't want a B on your transcript because then that's gonna drop the GPA. Okay? So just don't even think about it right now. We'll talk about it in January. Let's just get through our derivative unit. Okay? All right. Log base 3 of x. Our derivative. 1 over what's inside, but since we're not base e, we have to multiply by natural log of the base in the denominator. Okay. With this second problem that I have up here, 3x is inside. Okay? The only thing that it's going to change is we're going to do 1 over 3x times the natural log of the base. And since we have something other than x inside, we do have to multiply by the derivative of the inside. Which, yes, you could simplify, but I don't care if you do. Questions so far? How about this one? First of all, what's our base? 10. If there's no base, we assume it's 10. That's the common base. That's what's in your calculator. Okay. So go ahead. You try this derivative without me. Take like 20 seconds. Talk about it with your pot if you would rather. Talk about it or write it down. Got done? All right. Thank you. take this derivative. It's a logarithm, so 1 over what's inside. It's not base e, so we need to multiply by the natural log of the base. We have a composite function, so chain rule. The derivative of the inside, negative sine x. Is that what you had? Okay. Last straightforward example. You and your pod come up with an answer. Yeah. This one. No. Don't enter anybody. Autumn. It's their own little world.
Also, over all 4 semesters, I'm going to go to every year.
Okay, Mandy, do I guess? What'd you do?
I did 1 over the natural log of 10 because it's the base. So there's the base.
Yep.
And then the inside, which is x squared plus 1. And then you multiply that by the derivative of the inside, which is 2x.
I feel about that. Just make sure you put parentheses around x squared plus 1 so that when you multiply it to the natural log of 10, it's to all of it. Okay? All right. In our last 9 minutes of class, we're going to talk about something called logarithmic differentiation. Please write down this equation. Y equals yuck is what you're thinking. And that's okay to think that. Do you see any logarithms in this equation? No. So are you confused why we're talking about it or why the title of the slide is logarithmic differentiation?
Yes.
Okay, good. That's not all right. If we did not know anything about logarithms or what they could do to help us, when we take this derivative explicitly, we would have, first of all, a quotient rule, but inside of our quotient rule, we'd have some chains. Do you agree? Okay. Some of you may not want to do that. So logarithms give us some options. Okay? Are we allowed to do the same thing to both sides of an equation?
Yes.
Yes, they balance each other out, right? So it is possible for us to take the log of both sides. Okay? Now, why would I want to do that? Because now we don't have to do the quotient rule anymore. Now we can use logarithmic properties to expand this out to where we have some basic derivatives to take implicitly. Okay, what, Turner?
Why are we doing natural log of both sides?
So that we can do this. Instead of having to come up here and take the quotient rule, we have the option of using our logarithm properties to write this as 2 natural log of x minus 2 minus 1/2 natural log of x squared plus 1. Okay? Now we don't have to do a quotient rule at all. Yeah, we have some chain rules, but they're not bad, are they? They're not going to be bad. Okay? But we are taking the derivative implicitly because now we have the natural log of y instead of just y equals. Okay? But we just talked about implicit differentiation, so we've got it under control. Okay? So now let's take the derivative. The derivative of the natural log of y. 1 over y times dy dx, because it's y. This right here is going to be 2 times the derivative of the natural log of x minus 2, 1 over the inside, times the derivative of the inside, which is 1. I'm not going to write it. Minus 1/2 of the derivative of the natural log is 1 over the inside times the derivative of the inside. Okay, are we done?
Yeah. No, you have to get dy dx.
Okay, we have to get dy dx by itself. How would we get dy dx by itself? Okay, we gotta get that y to the other side. So, dy dx equals, I'm gonna multiply everything essentially by y. We're gonna multiply it over, okay? So I'm just gonna make this look a little bit prettier. This is 2 over x minus 2 minus that 2 and 1/2 cancel to be x over x squared plus 1. I gave myself too much room. Yeah, that's right. Okay. Now, did this start off as an implicit or an explicit problem? This started explicit. And anytime you have an explicit equation, your derivative also should be explicit. So instead of writing our answer like this involving a y, you need to actually replace y with, we know that y is, was it x minus 2, the quantity squared, over the square root of x squared plus 1, right? Okay. Now I know that that looks kind of, but our alternative was to do the quotient rule. Okay? So some of you might say, you know what, I'd really rather do the quotient rule instead of this. Some of you may think, you know what, I like this logarithm thing. Either way, I'll be very straightforward with you. I'm going to ask you specifically on the quiz Friday, please use logarithmic differentiation to find the derivative of a problem. Okay? You will have one of those problems. So I will expect this on Friday. But after Unit 2, you have the option if you want to use it or not. But it could make your life easier if you choose to do it. Okay. Questions on how I wrote the answer or the y or any of that? Yes? So the only reason why I say x can't equal 2 because when we take the derivative, it goes into a denominator. So that it's really not important for the derivative. Okay. Other questions? Okay, I think your homework comes from 2 different pages tonight. Really, there's 1 page of natural logs and 1 page of log base something else. Okay. Okay. Also keep in mind, we are continuing to add more rules. You remember that rule quiz that we took?
Oh, yeah.
It's not the last one.
Oh, yeah.